Okay, so the other type of problem from this section is if they actually give you k, they want you to find out if this particular, or find out the other zeros of this polynomial given a specific zero already. So again, this is sort of going back and using the factor theorem, but we're going to work backwards a little bit. So again, as a reminder, if k is a 0, then x minus k is the actual polynomial version of that 0. So, and again, related to how we did the last problems, if this is positive, then it's just going to get plugged right in for k, right? Because we want x minus k. If this is a negative number, then your 0 is going to be x minus a negative, right? So your 0 would end up being x plus 2. For this problem, though, our 0 is x minus 2. And that is where we're going to start off, do our jumping off for this problem. So this is what we're going to pull out in front to do the long division. Okay, so, and again, this should hopefully be a refresher. I'm going to kind of fly through it since this is covered a little more slowly in the problems from 3.2. So 2x to the third divided by x would give us 2x squared. 2x squared times x is 2x cubed. 2x squared times negative 2 is a negative 4x squared. Subtract everything on this line, so that becomes negative, that becomes positive, make that plus. Those drop out. We're left with a single x squared. Bring down our 17x, I'm sorry, negative 17x. Divide x into x squared, which of course is just a single x. X times x, x squared. X times negative 2, negative 2x. Subtract. So that becomes negative, that becomes positive. Make that a plus. Those drop out. Negative 17x plus 2x is a negative 15x. Bring down our 30 here. So I've got x into negative 15x, which of course is just negative 15. So negative 15 times x is negative 15x. Negative 15 times negative 2, positive 30. Subtracting everything on this line, so that becomes positive. This becomes negative. Everything cancels out, and you have a remainder of 0, which is what should happen, because this, we've been told, is a 0 of this function, which means we shouldn't have a remainder. So now, unfortunately, you're not done. So we know that this is a factor. Now we need to factor 2x squared plus x minus 15. Now, everyone has different ways of doing this, either by guess and check. I particularly like using the AC method, so I'm going to multiply 2 times 15, which gives me 30. And then I list my factor pairs for 30. 1 and 30, 2 and 15, 3 and 10, there's 1 and 4, 5 and 6, and then if I keep going, my next one will be 6 and 5. So I'm done with listing them. Now I need to find a way to combine one of these pairs using addition and subtraction to get a single x, or to get b, which in this case b is 1, right? Because that's technically the coefficient that's in front of the x term. So I want to find a way to combine a pair of these factors using addition and subtraction to get 1. And if I do 6 minus 5, that is 1. So what I'm going to do is split up this middle term here into these two pieces. 6x, oops, I'm sorry, plus 6x minus 5x. And then I've got my minus 15. And now I can factor by grouping. So I'm going to look for what I can pull out of my first two set of terms here. And I can pull out a 2, oops, my pen decided to stop writing, 2x. So what would be left behind is x because 2x times x gives us 2x squared, and then plus 3 gives 2x times 3 gives me 6x. Then I do the same thing over here. I can pull out a negative 5, and what I'd be left behind with is x is negative 5 times x is negative 5x, and then a plus 3 is negative 5 times positive 3 gives me negative 15. And in order for factoring by grouping to work, stuff on the inside of the parentheses must match. So from here, I pull together the stuff on the outside of the parentheses, put it together, 2x minus 5, multiply it by one of the terms that was on the inside, x plus 3, and then of course, our last factorized term for our original polynomial was the original 0 we started with. So our polynomial that we began with, 2x cubed minus 3x squared minus 17x plus 30, factors out into 2x minus 5 times x plus 3 times x minus 2. Yes, these are long problems. Should you choose to tackle one of these for the homework solutions, I will likely give you a lot of extra credit because they are so long. So, it's up to you, obviously. If you have any questions, please let me know.